All right, we're in week 12, section 1, Swyk 1. I wanted to remind you about something that you studied in geometry called SOHCAHTOA. That's where we're talking about, let's see if I can get my writing tools up here. Sine, cosine, and tangent. Remember those names, sine, cosine, and tangent? And we talked about using letters like, oops, I don't want to do that. Slide this up a little bit. Those letters stood for things like opposite. So if you're looking at this angle 39, the opposite side would be across the triangle from it. I always ask my students to find the opposite first. Secondly, find the hypotenuse. Okay, well that's always across from the right angle. Well, that only leaves one side left. The remaining side is called the adjacent side because it is next to the angle that you're talking about. So in this particular case, we have the opposite, and we want to know the adjacent. Well, that falls under the category of using tangent. So the tangent of 39, I always have my students set it up as a proportion, tangent 39. You can see that I put over 1. Nobody needs to really divide anything by 1 because we know that if you divide by 1, it's the same thing. But I set it up as a proportion because what we're about to do is called cross multiplication. That's how you solve every proportion in the universe. You might say, well, why do I have to do cross multiplication? Well, in some situations, it might seem ridiculous to think of cross multiplication, but in this one, it really will help you. So the opposite side is 43, the adjacent side is x. We're going to cross multiply this, right? 43 times 1, well, that's pretty easy. And then we have x times tangent 39. And so to get x by itself, we do division, right? And so when we divide, we end up with 43 over tangent 39, which is 53.1. Always pay attention to how they want you to round so that you get the answer correct. Basic sine, cosine, tangent stuff. We'll get back to more of that later. I want to remind you about some special triangles called like the 45, 45, 90 right triangle. You studied in geometry that the legs are both the same because it's an isosceles right triangle. And to go from here to there, without showing you the proof, because that's old stuff in geometry, the shortcut version of it is we multiply by radical 2. If we were going backwards, we would end up dividing by radical 2. You could take the hypotenuse and divide to get back to the leg. In this particular problem, they start out with a leg being 14, multiply by radical 2, you're done. That's it. Nothing more challenging than that. 14 radical 2 is the answer to the question. Okay, what about something like question 3? What if I have the hypotenuse and I want to go backwards? You divide by radical 2. Math Excel's not going to let you get away with writing 8 over radical 2. Technically, that is a correct answer. It will ask you to rationalize the denominator, as they always do. So multiply the top and bottom by that radical 2, which you and I both know that's radical 4 on the bottom, which that's why I wrote 2 right there. On the top, you just have the 8 radical 2. Well, anything outside the radical in the top and the bottom, since everything's being multiplied, nothing's being added or subtracted, we can do some simplification. 8 over 2 is 4. Notice that I did not simplify something inside the radical with something outside the radical. Can't do that. It has to both be outside or both be inside, as we've seen before. Okay, so that's how we go about handling that. We divide by radical 2, simplify if necessary. Okay, another type of question here, starting with that. We know that this other leg is 9. We know the hypotenuse, 9 radical 2, just multiplying. Question 5. Now we're dealing with a different one, the 30, 60, 90 right triangle. So everything is based on what we call the short leg, the one across from the 30-degree angle. If you want to know the hypotenuse, you double it. If you wanted to go backwards from the hypotenuse to the short leg, you'd cut it in half. If you want to go from the short leg to the long leg, you multiply by radical 3. Obviously, if you want to go backwards, you divide by radical 3. So let's take a look at this example right here. We're starting with the hypotenuse. Now, we said that The short leg is half of that, so we really will cut it in half, divide by 2. And then once we know that value is 15, we will multiply by radical 3 to get the long leg. So 15 over radical 3. Simple, done, not terribly challenging. At least not these. Here's another 30, 60, 90 right triangle. This time we're starting with, oh, hey, it's the same idea. We're starting with the hypotenuse and working our way back. Divide by 2, multiply by radical 3. End of story. We will be using that 30, 60, 90 right triangle a bunch more. Okay, last question for this Swyk. So you'll notice that I have a series of arrows that we can follow, starting with the hypotenuse of the 45, 45, 90 right triangle, which you see labeled right here. We divide by radical 2. That's nice because everything inside the radicals cancels, leaving me just plain old 4. So the C value is 4. Then we take that and we identify the A value. They have to be the same. It's an isosceles right triangle. Well, then we also realize that this is now a 30, 60, 90. So the 4 is now the short leg of the 30, 60, 90. If you want to get to the hypotenuse, you double it, right? So the B value is 8. And if you want to get from the short leg to the long leg, you multiply by radical 3. Done with that one. And that's the end of that Swyk. Have a wonderful day until the next Swyk. Bye.